So we saw P, which is a class of problems that are efficiently decidable, right? You have NP, which is a class of problems that are efficiently verifiable, but it is not clear if it is efficiently decidable, right? And P versus NP asks, is every problem that is efficiently verifiable also efficiently decidable or computable, right? Now some problems, so far we have been looking at time, but there is another resource which is space, right? It's the amount of memory that your machine takes. So if you are familiar with Turing machines, the amount of workspace that you take, right, to solve this problem, which roughly is the amount of memory. So you can also talk about space as a complexity measure, right? So maybe you are okay. So how much space does your algorithm for SAT take? The one that you said, run over all assignments, check if each of them is satisfied. What did you say? One of you should say. So how much space does the algorithm for SAT that you said? So you gave an exponential time algorithm for SAT, run over all possible Boolean assignments and test whether it is satisfiable. How much space does it take?
2n. Order of it.
2 times n or 2 to the n?
2 times.
2 times n. So it's not 2 to the n, right? So you use, first you look at all zeros, you evaluate it, you know the answer, you flush that space and reuse that space, right? So the same space can be reused. So the overall space is only linear, right?
So truth table one would increase the space.
So truth table,
Like if we take that one input.
so the input is given as a truth table. So workspace is still the same, except that the run time you will have to run over all possible, which is still okay. Actually, it's linear in your input. You are giving me truth table. I didn't ask for it. But so space is also a consideration. So you can ask algorithms that use logarithmic space, polynomial space, exponential space, and so on. So P space is the class of decision problems that have algorithms that use polynomial space. Okay. So I'll leave it as an exercise that every problem in NP is contained in P space. Okay. And every problem in P space is contained in X space. Is that okay?
So what is the definition of x? You are saying 2 to the power x1.
Right. So you say a decision problem is in EXP if there exists an algorithm that okay. So if you can read through the lines. If there exists an algorithm that correctly decides on all inputs, but the running time is 2 to the C. Okay. Some constant can also be there here, there.
So this constant will take the polynomial into account. Because we think polynomial belongs to exp. So
No, you say a decision problem belongs to exp. So SAT is in exp. Primes is in P. So primes is here, OCD is here, SAT is here.
these are all subsets and supersets.
Correct.
So polynomial belongs to exp.
Correct. So what you are saying is P is contained in exp. Yes. I mean, any function that is like mod x to the C is less than 2 to the mod x to the C. Correct. So P is contained, in fact, P is contained in exp, in fact P is contained in NP is contained in P space.
exp everything it is taking
Sorry.
less than 2 mod x.
So any exp algorithm is allowed to take this much time. You can take this much time. So SAT is in exp by the algorithm you gave. Primes is also in exp by the first algorithm you gave, but then Agarwal Kalpana gave a better algorithm that put it into. Right? So now you can ask, is there something here that's not here? Is there something here, not here, not here? Right? Okay. So SAT is in NP. Right? And there was this question, is NP contained in P? So what is the meaning of this? Suppose I wanted to say that NP is contained in P. How would I solve it?
So we can give polynomial time for any problem.
We have LP complete.
If it can be verified in
Which I have not said. So you should not use anything which I have not
Without
said.
that